All right, we'll go ahead and get started. Hello, everyone. On behalf of the Environmental Finance Center Network, we'd like to welcome you to the 10th session in our Operator Certification Series on OSHA and Safety Regulations. My name is Kristen Crew from the Syracuse University Environmental Finance Center. Before we begin, we're going to go over a few logistics and then we can get started. During the webinar today, everyone will be kept on mute to ensure audio quality. If you have a question, please type it into the GoToWebinar question dialog box anytime throughout the session. We will be saving your questions for a facilitated Q&A session at the end of the presentation. After the webinar, you will receive a follow-up email that includes a link to the recording and other information that you may need. You can also download the slides from today in the Handouts tab in your GoToWebinar control panel. This webinar has not been submitted for pre-approval of continuing education credits, but eligible attendees will receive a certificate of attendance for their personal record. To receive a certificate for this session, you must attend for the entire session and register and attend individually using your real name and unique email address. Certificates will be sent via email within 30 days of the webinar date. If you have questions or if you need assistance, please contact smallsystems@syr.edu. Now for a little bit about us. The Environmental Finance Center Network provides training and technical assistance to small water and wastewater systems in all U.S. states and territories through our building technical, managerial, and finance capacity programs. If your community or utility needs assistance with drinking water or wastewater system management, please feel free to contact us through our request form, which I will be sharing shortly in the chat. And on that note, we can go ahead and get started. I would like to introduce our presenter for today, James Markham. He's a research engineer from the Southwest Environmental Finance Center. Welcome, James, and I will hand it over to you.
All righty. Okie doke. Thanks again, everybody, for joining us today in our ongoing series on operator certification. Today, as Kristen said, we're going to be talking about OSHA and health and safety regulations, but also just the general topic of operator safety in the wastewater treatment context. I'll be focusing on a few specific areas because there's only so much we can cover in the allotted time, and safety is obviously a big topic. I want to start off with a pretty blanket statement. Safety is your responsibility. Be safe out there, make sure that others that you're working with are safe as well. Obviously, you're going to need to know a fair amount about safety and regulations in the context of the operator exam, but it's really important to keep safety in foremost in your minds on the job. It's really paramount. As operators, you're going to face work situations that include safety hazards, some of which are going to be obvious and some of which aren't. We want you to be aware of safety issues, make sure that you keep yourself and your coworkers and your community safe so that you can have a long and prosperous career in the wastewater treatment field. Every workplace has some risk of injury, obviously. This is made very clear in the training materials that are available for you, both for operator testing and various aspects of on-the-job training. You know, there's risk of physical injury from machinery and improper lifting and slipping, and there's infectious diseases you might come into contact with. There's confined space issues, which may have oxygen deficiencies. Potential to run into toxic vapors and gases and chemicals, radiological hazards, fire, electrical shock, noise, dust, and although it's horrible to think of in a wastewater context, drowning is a possibility as too. And of course, the purpose of listing these all is not to scare you away, but to make sure that you take these risks seriously and help create a safe working environment. Much of the Sacramento State Operation of Wastewater Treatment Plants manual that we've talked about in earlier sessions is devoted to safety. The entire second chapter is about safety, and every section dealing with the treatment process has a specific safety section in it. Again, we can't cover everything in a 1-hour webinar, but we are going to highlight some critical areas, and as always, remind you to look at your state-specific study and test materials to see, you know, what your jurisdiction emphasizes at whatever level of certification you're going to be taking. You know, you need to recognize that, where you're working now might have stricter rules than a different jurisdiction you worked in before. And it's really important to understand the regulatory framework where you are working, because as you will see, it differs a little bit from jurisdiction to jurisdiction. You really want to view your surroundings with your hazard eyes on. I do a lot of backcountry skiing, which is skiing outside of the resorts where there's no ski patrol. And we talk about having avalanche awareness to stay safe, which basically means, understanding the avalanche hazard, always evaluating it, carrying the right safety equipment, and most importantly, knowing how and when to use it, and the proper procedures for accessing dangerous terrain, completing rescues when they're necessary, etc., so that we stay safe and don't put others at risk. Because obviously, if we put ourselves in risk, somebody has to rescue us, and that puts them at risk as well. Sometimes there's a sign, sometimes there isn't, but ultimately it's on us as backcountry skiers to know when we're putting ourselves and others into danger. Avalanches are rare, but they can kill you. So, when we're out in the backcountry, that's something that we evaluate and reevaluate. And that's really not a bad way to approach on-the-job safety. Evaluate and reevaluate. When you get too comfortable, you get careless, bad things can happen. And sometimes those bad things can lead to serious injury and death, not to mention fines and everything else that can go along with the violations associated with what got you hurt in the first place. Point I'm making here is nobody wants to be the headline. People are often bad at assessing risk and overconfident in outcomes, particularly when prior risky behavior has not led to negative consequences, or when there's an emergency situation and you're in a panic. And that's why we have regulations, SOPs, personal PPE, and safety training to make sure that we're prepared and that we do things correctly in a way that mitigates the risk of injury to everyone involved. Obviously, different aspects of your work are going to have different hazards associated with them. With a lift station, you're dealing with confined spaces, electrical hazards, slip hazards, the possibility of drowning. If you're dealing with excavation, there's a different set of issues that you're dealing with. Cave-ins, falling equipment, getting hit with carelessly slung pipe, that sort of thing. The point I'm making here is it's really important that you as operators recognize the safety issues that you may face in any given situation and understand how to react to them. They're going to vary, and as operators, particularly operators working for small systems where you often have to be a sort of jack of all trades and do all of the things, you have to really, again, be responsible for yourself, for your employer, your coworkers, your community, and the communities downstream of you. Safety is your responsibility, and quite frankly, working safely is a condition of employment. If you're someone who is continually skirting safety regs, there's a very good chance you're going to lose your job. It's also really important to recognize that most utility injuries are actually caused by the injured employee themselves. It's not always the case, but if you look at OSHA case studies, most often people get hurt because they are willfully ignoring regulations and putting themselves in danger. So with that, we're going to move on to our very first question, just to see if everybody's awake here. Kristen, if you want to throw that up there, this is a pretty straightforward question about physical injury.
All right, James. Operators can experience physical injuries caused by A, moving machinery, 2, improper lifting, 3, slippery surfaces, or D, all of the above. And James, we had someone had made a comment that your audio is sounding a little bit muffled.
Okay, let me switch audio interfaces and we'll see if I can improve that.
All right, and on that poll, it looks like 98% got the answer correct with all of the above.
Exactly. There are really no wrong answers here, but one is righter than the others, and that's all of the above. Hopefully, the audio is a little bit better now.
It does sound more clear, yes.
Okay, great. All right, so as I said, we're going to talk a little bit about OSHA. The big safety watchdog in the United States at the federal level, the occupational safety and health regs, which are found in 29 CFR, mostly in 1902 and the following sections, are there, and they're administered by OSHA, the Occupational Safety and Health Administration, a little bit of a tongue twister, which is part of the US Department of Labor. The administration was created in 1970 when President Nixon signed the Occupational Safety and Health Act into law, and it covers most private sector employees and their workers, in addition to some public sector employers and workers in the 50 states and territories and jurisdictions that are under federal authority. Of course, there's a lot of different kinds of legal entities that run wastewater treatment facilities. Some are private, some are public, but as an operator, you're probably covered. And as a test taker, you really are responsible for having a basic understanding of the regulatory environment in your jurisdiction. OSHA has a really wide reach. So as you're prepping for your state exam, make sure that you look over the safety regulations. Part of that, again, partially to pass the exam, but more generally just to keep yourself safe. And I do want to point out that although I do have the OSHA logo up here, this is not an OSHA sponsored webinar. We're just using them to show who's in charge of this. OSHA's mission is to assure safe and healthy working conditions for working men and women by setting and enforcing standards and providing training, outreach, education, and assistance. The OSHA Act covers most private and sector employees in all 50 states, but like the NPDES program under EPA that we talked about a few sessions ago, in some jurisdictions, state agencies have actually taken on the responsibility for enforcing those occupational safety and health regulations. These approved state programs effectively take the place of OSHA, but the state plans are approved, monitored by, and partially funded by OSHA, and they're still enforcing essentially the same regs, and in some case, maybe recommending more stringent conditions. Again, the OSHA standards that apply to wastewater practices are found throughout 29 CFR. There's some that are there for general industry that apply. CFR 1926 covers confined spaces, 1910 covers bloodborne pathogen standards, etc. As I said, there is a wide-ranging regulatory environment here. There are 22 states and territories that have OSHA-approved state programs. So the state is actually going to be doing the enforcement. So Alaska, California, Arizona, Hawaii. I'm not going to name all those states, but if you're in one of those, you'll probably recognize yours. Puerto Rico's down there as well, not a state, but they have their own program there. There are also 5 states and 1 territory that have OSHA-approved programs that cover all public sector employees: Connecticut, Illinois, Maine, Jersey, New York, and the Virgin Islands. The point here is that the jurisdictional environment varies a little bit from state to state, and you really need to know who's enforcing what wherever you are working, because if you've moved states, it may have changed. So, beware of local occupational safety and health regulations. Recognize that, in California, OSHA regs are enforced by the Department of Industrial Relations, which is sometimes known as Cal OSHA, whereas in New Mexico, it's under the New Mexico Environment Department. So it's going to vary depending on where you are. And the reason you want to focus on your specific jurisdiction is usually your testing materials will tell you what parts of the OSHA safety regulations you're going to be responsible for knowing. So for example, in New Mexico, you have to know about PPE, like steel-toed boots, gloves, face shields, and goggles, when to use them. You need to know about confined space entry. You need to know about equipment lockout and tagout procedures. You have to understand hazard chemical communication standards, primarily the material safety data sheets, which we'll talk about here in a little bit, excavation safety, and bloodborne pathogens. This is not the entire list of things that you need to know to do your job, but in New Mexico, these are the things that at a minimum you should cover to be able to pass the test. And then also recognize there are things you need to know to pass the test, and there's things you need to know to keep you safe. You don't want to be book smart and on the job not smart. So let's talk about safety sort of in general, and then we'll talk specifically about some of these specific areas of safety regs and requirements that might apply to you or will apply to you. So safety programs are everybody's concern. They're there to keep us safe. All wastewater utilities, regardless of size, have to have a safety program to systematically address workplace safety, health standards, hazards on an ongoing basis to reduce the extent and severity of work-related injuries and illnesses. They're there to identify the causes of accidents and illness and injuries, to provide safety training, to implement an accident reporting system, and to hold supervisors responsible for implementing the program. And I think this last one is really, really important, because if just the employees and the safety officers are being held responsible, the program's likely to fail. This really needs to be a top-down and bottom-up approach. As an operator, it's your responsibility to, understand your safety program, ask about it, participate in it, follow the safety protocols and standards that are there when you're doing your job, use your safety equipment, scuba, hard hats, goggles, other PPE as appropriate, and to report safety hazards and injuries. You see something, you say something. It's a two-way street though. Management has responsibilities as well for developing that written safety statement, establishing the safety program, assigning responsibilities for injury prevention, appointing a safety officer or coordinator, establishing realistic goals and revising them to encourage continual improvement, and evaluating the results of your safety program. And again, I think this last point is really crucial. The only way to know if something is effective is if you track it and measure the outcomes. This is why all injuries should be reported, why we have reporting programs, so that we can stay on top of things, verify that our safety program is working, and if it's not, make adjustments to make it work better. Safety training programs have sort of three critical components: safety training of all employees, reinforced education in safety, and safety education in the use of tools and equipment. In other words, education, education, education. It's kind of redundant, but it's really important. Safety is not a once and done thing. You don't just get your safety orientation as a new hire and be done with it. That's important for new operators, but ongoing training, safety reinforcement is really important, particularly with new job duties as they're learned. Recognize that, as we stated in the opening, there's a lot of different considerations for different aspects of the job. There's going to be specialized training required for different kinds of work, like confined spaces and water-filled structures and other hazardous areas. There may be risks that you're aware of and risks that you are not aware of, and doing that continuing education is going to help with developing and maintaining that awareness and keeping everybody safe. This is kind of a good point to point out that tailgates aren't just for parties and barbecues. It's a great place for safety meetings. It should be part of ongoing training, particularly at new job sites or operations, to make sure that safety is foremost in everyone's mind and that everyone has an opportunity to ask questions, get on the same page. And I don't just mean at tailgates. I'm referring to sort of short informal meetings held relatively frequently, just to make sure that safety, again, is foremost and paid attention to. What we're looking for here is the safe workspace there in the middle of the bullseye. And it's really important to recognize that there is a layered approach to safety, and that's a good way to approach it. Our goal is that safe workspace in the bullseye, or the middle of the safety onion that I like to call it. And we've got various layers of preventative measures that we can implement that get more and more effective as we go toward the center. PPE is a great start, having safety glasses, having hard hats, protective shoes. It's better to have work practice controls in place, like safety training programs and engineering controls, physical barriers to prevent you from getting hurt, so that the PPE doesn't have to be the thing that keeps you safe. Further in, we've got the idea of substitution and elimination. So for example, putting in an automatic sampling process that eliminates a manual sampling process that might be risky because somebody's out up over a tank, or eliminating things that could cause danger, like properly disposing of chemicals and flammables. So it's a layered approach. Everything reinforces the other bits. But again, you need to sort of think big picture, but also specific to the job that you are doing. So brief overview of safety program basics. Again, we cannot cover everything, but before we shift gears here and talk about some specific safety related topics, I have another quick question for you. Kristen, if you can run the second one.
Who has the most to gain from a safety program? Management, office staff, operators, or supervisors? All right, get those answers in. I'm closing the poll. 3, 2, 1. And 87% of folks answered correctly with operators.
Yeah, exactly. You know, the operators are the most likely to be injured because they're the ones on the front lines. Again, this is one of those questions where all of the answers is right, but one is more right than others. Obviously, everybody involved benefits from the safety program, but the frontline employees benefit the most. All right, let's switch gears a little bit. Let's talk about some specifics like infectious materials. As a wastewater operator, you're likely to come into contact with all kinds of microorganisms that have the potential to cause illness. You know, bacteria, protozoa, parasitic worms, and viruses. There, are typhoid, polio, hepatitis A and B, tetanus, things like that that you can run into. Cholera, dysentery. The picture that you're looking at there is actually cholera. It's a really good idea to check with your safety officer about getting inoculated for the things you can get inoculated for, and to be very safe and use your PPE for the things that you can't. It's a good idea to assume that every surface is contaminated. Use your PPE like gloves, when handling hazardous samples, when you come in contact or might come in contact with wastewater or sludge. Obviously, this is not an exhaustive list. It's, again, meant to show the risk and point out that there are things you can do to mitigate that risk. That's why we have PPE. On the subject of wastewater and sludge, water safety is a big concern in wastewater utilities. There are slip hazards on catwalks. In icy weather, those become even more dangerous. So you want to do something about reducing slip hazards, using extra caution in wet weather, keeping handrails in good repair, replacing damaged rails, marking and guarding unsafe areas, making sure that you have emergency gear near places that are hazardous, like filters and tanks and basins, and clarifiers, like safety vests and buoys and life poles, and more importantly, knowing where they are and how to use them. Learning how to swim is really important. Obviously, you don't want to avoid using a personal flotation device where you should, even if you can swim. But if you don't know how to swim and you're working in a wastewater treatment plant, I suggest that you learn how to. So another question, there's no prep for this, but this is just a useful thing to think about. If you can run the next question here.
If you fall into an active aeration basin, will you always be able to swim out? Yes or no? All right, most people have their answers in, so I'm going to go ahead and close the poll. And 91% of people answered correctly with no.
Yeah, so there's a couple of specific dangers related to aeration basins. One is the aeration itself affects buoyancy. If you fall into an active aeration basin and nobody turns it all off, you're going to be less buoyant and it's going to be harder to stay afloat. There's also the danger of currents, moving equipment. So, if you fall into an active aeration basin that's going full blast and you aren't wearing a PFD, there's a very good chance you're going to sink to the bottom. So again, this is the kind of thing that you may or may not be aware of. It's probably not going to happen to you, but you want to be prepared and you want to make sure that you fully understand the risks involved with your day-to-day operations. Let's talk a little bit about electrical hazards. Operators come into contact with electricity, or have the potential to come into contact with electricity in a lot of different places. Wastewater treatment plants have transformers and starters and motors and instrumentation and control panels and voltages running from, regular house current 120 volts up to kilo voltage ranges, with power coming in straight off the power lines. So let's answer a quick question about electricity here. So again, just a short yes or no question.
Can 120 volts kill you? Yes or no? All right, and I'm closing that poll in 3, 2, 1. And most people answered correctly. 97% said yes.
Yeah, 120 volts can definitely kill you. It is somewhat situational, but any voltage is dangerous. 12 volts can injure you if the amperage is high enough. It's not the volt that necessarily kill you, it's the amps. I'll talk about some specifics about that here in a second, but recognize that, you know, despite the fact that we've probably all been shocked by household current and had nothing worse than, you know, a tingling arm, electricity is dangerous. 120 volts can definitely kill you. So you want to make sure that you know, do proactive maintenance to identify performance and safety issues that might lead to getting somebody shocked ahead of time. You know, make sure that you're using non-conductive tools when you're working around electricity, assuming that you are qualified to work around electricity. Because again, this is one of those things where if you don't have the training, you shouldn't be doing it. Don't use electrical equipment with worn or frayed cords. The last thing you want to do is have sparking equipment or equipment that could short and hurt you, particularly if you're in an area where, for example, there are potential for flammable gases. You know, I saw a video a couple of days ago of a guy starting an acetylene torch with a faulty electric screwdriver because it sparked. That's not what you want. Obviously, permanent wiring should be installed with conduit or armored cable by a qualified electrician. You want to replace worn connections or thinning insulation. You know, the insulation is what keeps you safe. So if you notice something, fix it or say something so somebody who has the appropriate skill and training can do it. You know, use 3-prong grounded plugs. That they're there for a reason. They're there to keep you safe. Make sure that you're aware of things like overheating equipment or tingling feelings through your hands that might be an indication that something is starting to short out or that you're becoming part of the circuit. Make sure that when you're in areas with flammable vapors, that you're using explosive proof electrical units. And obviously when you're doing electrical work and most safety work, quite frankly, you should be working in pairs so that if something does happen to the person doing the training and there's somebody there who can effect a rescue. I want to go back to the current and voltage thing a little bit just to sort of explain why voltage, even relatively low voltages like 120 volts can be dangerous. Current is essentially the voltage divided by the resistance. Voltage is obviously measured in volts. Resistance is measured in ohms. Your body will provide resistance to an electrical current if it becomes part of the circuit. And depending on where that, what part of your body is part of the circuit, the resistance is going to be different. So for example, if your head were to become part of a circuit, you know, and current was going ear to ear, your body would offer about 100 ohms of resistance. If the circuit was, you know, from one of your hands through one of your feet, we're talking about 500 ohms roughly. The wet skin, dry skin thing there is to show you that wet skin lets a lot more electricity through than dry skin does. So I'll show you here why, for example, an ear-to-ear circuit can kill you. So 120 volts divided by 100 ohms is 1.2 amps. If you pass 1.2 amps of current through your brain, you're going to die instantly. Again, something that you know, shock in your hand might not be that big a deal, but if it went through your head, it could kill you instantly. But even a 120 volt shock hand to foot could do serious danger or damage to you. I mean, it's about 500 ohms, give or take, about 240 milliamps, could severely burn your internal organs, could possibly kill you. And again, wet skin lets more current flow through the body than dry skin. So, you know, all of the scenarios that you can think of are going to be infinitely worse if you're wet. And the reason, you know, because electricity is so dangerous, we have things like lockout and tagout programs. It's one of the best ways to avoid accidental electrocutions is by essentially removing the thing you're working on from the electrical circuit, physically locking and tagging it out, and following very strict protocols when you take the item out of service and when you put it back into service. Basically, if you're going to have to work on some electrical equipment, there's sort of a list of things that you should do before you start work. Notify affected employees that the tagout procedure is going to be used and why. Shut down the equipment using whatever normal shutdown procedures you have. And if you don't have some, you need to develop them. It's a good idea to have those things written down. Checklists are great because that's a great way to avoid making mistakes. You want to isolate the equipment from the energy sources. So whether that's flipping a switch or, you know, opening a breaker up, and ensure that the stored energy inside is dissipated. That second part is really, really critical. In addition to skiing, I play electric guitar. I work on my own equipment. A lot of people work on their own amps, and every year people are killed because they forget that there are capacitors inside guitar amplifiers that hold really, really high voltages. And even though the amp is unplugged from the wall, that capacitor is still holding a lot of juice and it's enough to hurt you. That energy could be stored other ways too, in springs or something like that. So the point here is, isolate the equipment, make sure that any energy that's available in it is dissipated. Then you would lock it out and tag it out. So the lock is a physical lock that prevents the circuit from being closed. The tag is there to indicate why it was locked out, who locked it out, and potentially when it's going to be locked back in, or what's going to happen next. With the assigned individual lock and tag, it's a good idea to have a separate lock and tag for each thing that might potentially be locked out, so that you don't run short of them and then cut corners. Once you've done that, reconfirm the circuit is dead. It's just like in carpentry, measure twice, cut once. You want to double check the circuit's dead, ensure that the energy source is disconnected, making sure nobody's exposed, and only then do you start work. And obviously, when you're going the other direction, it's basically this entire process in reverse. Remove your tools, everything gets returned to working order, ensure employees are clear, and remove the lockout and tagout devices, and then notify everybody that it's been removed, and then restore power. So on the subject of electricity and tagouts, we've got a question for you.
Who should remove locks and tags from electrical equipment? The operator who needs to use the equipment next, the operator who locked and tagged out the equipment, any operator that is qualified as an electrician, or any operator on the next shift. All right, and get those answers in. I'm going to close the poll in 3, 2, 1. And 92% said the operator who locked and tagged out the equipment.
Exactly. In general, that's the standing rule. Never remove equipment that someone else installed unless your employer has specific procedures and training in place for removal by others. Because obviously, some work on electrical equipment is going to span multiple shifts and have different people involved in it. But the general rule is, if you didn't put it on, don't take it off, because somebody might still be working on something. And the annoying thing about electrical circuits is sometimes they're very long, and the lockout might be quite far away from the actual equipment that's being worked on. So the last thing you want to do is unknowingly put someone else in danger. All right, enough about electricity. Let's move on to chemicals, and specifically the materials safety data sheets. There are a lot of potentially dangerous chemicals in a wastewater treatment plant that can, if handled incorrectly, cause accidents and exposures with chronic and acute effects. It's really good to understand the chemistry of the substances that you're working with, how to store them, how to use them safely, how they can potentially affect you and others if they're released, and what to do in the event of an accidental exposure. Knowing things like boiling point, flammability, explosive limits, reactivity, and possibly most important, the first aid for each of the chemicals that you use is really important for safe use. There is potential for burns, respiratory difficulty, eye damage, rashes, skin damage, headache, and even death from some of the substances that you probably use on a routine basis. They can have acute or chronic effects. So acute effects are things that essentially happen with contact, sometimes almost instantaneously. Often those will resolve when you're no longer in contact with the substance, or when you've got medical treatment, but not always. And sometimes the acute reaction is death. Chronic hazards are ones that might not appear immediately or after a single exposure, and they also may or may not be reversible. So if we think about chlorine, commonly used chemical, an acute effect of a chlorine exposure might be something like eye irritation or blurred vision that might clear up once you're out into the fresh air. On the other hand, if it's enough chlorine, the acute effect of the exposure will be death. Chronic effects that you can get from, example, from long-term low-level exposures to chlorine, or permanent lung damage, which leave you with permanent coughing and wheezing. So it's really good to recognize, that some materials have acute effects, some have chronic effects, some have both, depending on the type of exposure. Some hazards have immediate impacts, others creep up on you. You want to make sure you understand what the potential dangers are for the substance that you're working with. You're going to be working with a lot of common materials, common acids that you might see in a wastewater treatment plant, or things like acetic acid, hydrochloric acid, nitric acid, and sulfuric acid. Some of these are going to be used in treatment processes. Some might be used for cleaning. Acids react incredibly violently if they're exposed to alkaline materials like ammonium nitrate or potassium hydroxide. When you're using these PPE, like goggles and gloves are a must. The last thing you want is this stuff on your skin, particularly since the concentrations that are typically used are very, very high and can do damage very, very quickly. Acids, obviously, on the low end of the pH scale, the lower down on the pH scale you get, the more acidic something is. The opposite end of the scale is bases. Things like hydrated lime, calcium hydroxide, quicklime, caustic soda, hypochlorite for disinfection, sodium carbonate and soda ash. These are things that you also could use for treatment. They're typically used to raise pH in treatment plants and for some disinfection purposes. These things can attack human skin really, really quickly and cause burns. If you've ever gotten household bleach on your hands and felt that slimy feeling, that's your skin dissolving. And that is a much lower concentration than what you probably have in a plant. These can have explosive reactions if they come into contact with acids. Again, goggles need to be worn at all times working with these, particularly due to the strong hazards that bases present to eyesight. But also recognize not everything here is going to necessarily react in explosive manner. Quicklime won't necessarily explode, but when you mix quicklime with water, it generates a lot of heat, and that's something that you have to be aware of. There's obviously a lot of other chemicals that you're going to encounter: chlorine, methane, hydrogen sulfide, other gases. Some of those are going to happen in the plant. Some of those might happen out in the collection system. Even things like activated carbon can be dangerous if it's in dust form, because dusts can explode. You hear about grain silos exploding. It's because of the dust. Some things like activated carbon under the right circumstances can have similar reactions. The good thing is there are some really common methods for identifying and communicating chemical standards that you really need to become familiar with at site. And I'm going to talk about two of them today. The first one being the fire diamond or safety square from the National Fire Protection Association. This is an icon that you will probably see on many of the chemicals, if not most of them, in your facility. It's got 4 boxes: the blue one for health hazards, the red one for fire, yellow for reactivity, and then specific hazards fall in that white box. And the first 3 are ranked on a 0 to 4 scale, where 0 is basically stable or not flammable, or not really a health hazard, and 4, and the health hazard is deadly. Something that's a 4 on the reactivity side might detonate by itself. The fire hazard basically lets you know under what circumstances that's likely to ignite. And then specific hazards are denoted in that white box, whether something is an acid or alkali, or it's corrosive, or it's radioactive, or maybe if you should not use water around it. This system is primarily designed for emergency response staff. So that they can very quickly look at something. For example, if there's a fire and the fire department shows up, they can very quickly look at what they're dealing with and recognize what the dangers are. You as plant operators might be doing emergency response as well. And again, this is sort of a quick way of giving you an assessment of what you're dealing with. If there are labels like these on chemicals, don't take them off. The other standard that you really need to memorize is OSHA's Hazard Communication Standard pictograms, the HCS system, which are shown here. And you can see there's similar to what was shown in the prior slide, but a little bit different. There's health hazards, flammability hazards. There's the exclamation point for various kinds of irritants and physical effects. The gas cylinder lets you know that there's gases under pressure. The one in the middle is corrosion. The one side is essentially a test tube falling on metal. The other side is on your hand. Things that are self-reactive or possibly explosive will be donated, called out with the bomb pictogram. Oxidizers have that circle over flame. Something that's going to be toxic to the environment, particularly to the aquatic environment, will have that one in the bottom and the middle. And then, of course, the skull and crossbones indicates acute toxicity, which could be just, get you really, really sick, or could kill you. You really need to memorize all of these and recognize that they're broad categories. If you look at the health hazard set, things can be carcinogens, respiratory sensitizers. There are a variety of different kinds of effects that fall under health hazards. Same thing goes with the others. These will show up, on the packaging and on the material safety data sheets that go with every chemical that you have. Your supplier should have a material safety data sheet for every chemical that you buy from them, you can get from them. You should have them on hand, and if you're using the chemicals, you should read these thoroughly and understand all of the pieces. Each one of these is set up exactly the same, regardless of what vendor they come from, and they've got 16 basic components that we're going to go over here really quickly. There's the identification piece, which tells you what the product name is and other names that it may go under, because some chemicals have a variety of different names. There's the hazard ID part, which includes some statements and whether something's corrosive to metals or does eye damage, etc. It also includes the pictograms we just talked about and some prevention and response to exposure information. There's information about the composition. So for example, this happens to be somewhere between 90 and 98% sulfuric acid, which means it's really, really potent. First aid measures, really important to read. Again, knowing what to do in the event of an exposure so that you don't make the problem worse is really important, particularly when you're dealing with some of the hazardous chemicals that you have in the plants. There's firefighting measures. So what to do if the chemicals that you're dealing with here are exposed to flames or in a fire. What you should do if it's accidentally released, how to handle and store it. PPE to use to limit your exposure protection or controls. Physical and chemical properties. So, what the boiling point is, what the melting point is, whether it's heavier than air, whether it's soluble in water, what it looks like. The last thing you want to do is walk into a room with a chemical that doesn't have a label on it. Again, as I said, never take labels off of chemicals. Whether it is stable or reactive. The information here is on the next sheet on this particular one. So you can see, sulfuric acid, is it a reactivity hazard? Yes. Is it stable? It reacts violently with water. These are the kinds of things you want to know so that you can work with this stuff safely. Toxicological information, whether it's poisonous or not, and under what circumstances. Ecological information, which is going to lay out what this will potentially do to the environment. Disposal considerations, so how to dispose of it properly, how to transport it, any other regulatory information that's pertinent, and last but not least, the all other category for anything that for some reason or another was not covered in the prior sections. Get to know these. Categories show up on tests quite frequently, and again, they are really critical for keeping you safe in your day-to-day work. So in the context of material safety data sheets and safety in general, let's talk a little bit about chlorine. I'm not going to go too deeply into this because we talked about this quite a bit in the disinfection webinar we did a while ago. But we know it typically comes, at least chlorine gas comes in tanks like this or larger ones, and there are a variety of effects from exposure. At very low exposures, you might get some throat irritation or coughing. High exposure, 1,000 ppms can kill you after a couple of breaths. The one on the top is bolded. That's the OSHA ceiling limit. Good thing to know. But NIOSH recommends an exposure limit of half of that as a weighted average per 10-hour workday. So, something to consider. Most people can detect chlorine at low concentrations, around 0.3. But one of the effects of chlorine is that it deadens your sense of smell. So if you're exposed to a low level of chlorine for a long time, you might think it's gone away, and the issue might actually be that you just can't smell it anymore. Again, we talked about it pretty in depth in the disinfection webinar. The point here is chlorine, if it's mishandled, can kill you, and all of that information is available on the chlorine material data safety sheet. I got 5 of those nasty icons we showed and other information. So the good thing is, if you read these, you have an understanding of what chlorine can do under what circumstances, how to transport it, how to deal with it. It shows here it's an oxidizer, it's under pressure, it can explode if heated, it's acutely toxic, it's corrosive, toxic to aquatic life. So you probably know about your safety equipment, and I'm using chlorine here to basically point out that having safety equipment is great, but it's really important to know where it is, how and when to use it, and how to maintain it. So, for example, if there was a chlorine leak in the room and you were in there, you'd probably grab something like this, a respirator with cartridges to get out of there. It filters out chlorine gas, so if there's a leak, you get that on. It protects your eyes. Protects your lungs and gets you out of the place. It's important to understand that this kind of gas mask is for escape purposes only, because what's in that room can kill you, the chlorine, but what's not in the room could just as easily kill you if that chlorine displaces a lot of the oxygen in the room. And all this PPE device does is separate the chlorine out and make sure you don't get the chlorine in your lungs and in your eyes. If you're in a room and the oxygen level drops below 12%, you could die because there's not enough oxygen to sustain you for the long term, even though all the chlorine is getting filtered out by your gas mask. This is also the reason why you never really want to crawl out of a room where there's a chlorine leak if you can avoid it, because chlorine is heavier than air. It'll sink to the floor. It'll displace the air that's there. And by going to the floor, you may actually be putting yourself into an oxygen depleted area, and you might pass out before you realize the danger. So again, what point here I'm making is that there are different kinds of PPE. There are different scenarios. There are different kinds of things you want to do in different exposures, and it's really important to know what equipment to use, what the equipment will do, what it will not do, so that you use it appropriately in the given situation. The appropriate piece of equipment to use if you were going into a room where there had been a chlorine leak for some reason would be something like a scuba system, self-contained breathing apparatus. It's got your own oxygen supply for a limited time, but even this requires specific training to use properly. If you haven't been trained on one of these things, the last thing you want to do is wing it because you're liable to get hurt. And again, you don't want to be the headline. Poorly maintained and located PPE and rescue equipment can be worse than none at all because it gives you a false sense of security. In my prior career, before I moved into engineering, I was an attorney. One of the first cases I worked on involved a fishing boat that sunk in the Bering Sea. They had life rafts and dry suits for the crew, but most of the crew died anyway because half of them weren't trained to use the equipment, and most of the equipment that was there either wasn't accessible or was so poorly maintained that it didn't function correctly when it was needed. And again, people died because safety regs and safety programs were ignored. The point of that is, again, don't be the headline. Let's talk briefly about confined spaces. This is something you run into a lot in the wastewater treatment and out in the field. Manholes specifically are confined spaces. Confined space entry is covered by OSHA regs. There's an entire section about it. The OSHA regs related to confined spaces are typically found in the operator safety section of most test guides. So what's a confined space? A confined space is a space that's large enough and configured so that an employee can bodily enter and perform work. In other words, you can get in there to do work, but it's got limited or restricted means for entry and exit. It's not designed for continuous occupancy. Entry into confined spaces require entry permits, and there are specific procedures that you need to go through before you enter them and while you're in them, because confined spaces have the possibility of being oxygen deficient, particularly in the manhole situation. You've got the possibility of toxic vapors, explosive vapors. You could have an oxygen enriched atmosphere in some enclosed spaces. There could be explosive chemical dust. All sorts of things can happen in confined spaces. So you want to make sure that you have the appropriate checklist and you follow it rigorously. Again, manholes are confined spaces. Again, deadly gases can be in there, and that's why we have things like atmospheric testing and ventilation, like we're showing here. Because this is the kind of thing that happens on the routine. Sewers have to get cleaned, blockages have to be removed, work has to be done down there, and it can be done safely or it can be done dangerously. Just to get back to oxygen again, this is something that you might want to sort of commit to memory. Normal air is about 21% oxygen. Anything under about 19.5% is potentially dangerous. Shortness of breath kicks in around 17%, between 7 and 10%, 6 and 10%. Rapid loss of consciousness happens. And if you're in an area that has less than 6% oxygen for more than a few minutes, it will kill you. And there's a lot of reasons that oxygen can be depleted, in a sewer or another area. Bacteria could be using up available oxygen. So aerobic bacteria, we talked about that a little bit in the context of treatment. Other gases might displace oxygen. Chlorine's heavier than air. So if a room fills up with chlorine, all the air gets pushed out the vents. Even rusting, oxidation of metals depletes oxygen to some extent, as does combustion, which again is why we have permits, why we have monitors, why we have checklists. These things are really important. They should be used. If you're out on a job and your monitor battery dies and you don't have a backup, you don't go in the hole. You fix that before you go in there. Obviously, the exact procedures and the paperwork for confined space entry is going to vary from place to place. So again, look to your local rules. Your utility should have a procedure for this, and if they don't, you should get one. The last thing I'm going to talk about here really briefly is excavation hazards. When there's a trench collapse, without adequate cave-in protection, there is usually no warning and no time to escape. These are the kinds of things that, 1 minute you're safe and the next minute you're dead. The OSHA regs require protection for excavations if the trench is 5 feet deep or more. I talked earlier about making sure that you understand your local regs and recommendations. And this is an example of that. In New Mexico, NMED recommends protection if the excavation is 4 feet or more in depth. And that is a question that happens to come up fairly frequently on the New Mexico exam. So in this case, the New Mexico recommendation is actually more stringent than the OSHA requirement. So you want to check your local requirements and make sure that if you are doing excavation, you're doing it properly. There are 3 kinds of protection that you can use when doing excavation. There's shoring, there's shielding, and there's sloping. These are terms you should commit to memory, and there's some specifics about them that you should also commit to memory. Shoring is essentially using a wooden or metal framework to support the walls of the trench. So this one happens to be a wooden box that's there to prevent a cave-in. This is a metal version in a long trench. It's basically supporting the walls of the trench and keeping you safe inside. Shielding is essentially sort of shoring in the small version. It's using a trench box, something like this. This happens to be sitting on its side. Normally what's on the pavement and sticking up in the air would be in the ground like this. So it's placed in there, and the idea is that as long as you are between those 2 plates, you are safe. The point here, though, is that you are only safe if you're between the 2 plates. This guy out here in the front is kind of in the danger zone and probably shouldn't be there. If you're using a trench box, make sure you still stay between the plates. If you need to do something outside of those plates, move the trench box. Don't step outside of it and do a bunch of work because you're basically just putting yourself and everybody else at risk. Last thing is sloping, which is what you see here, which is essentially taking your vertical trench walls and sloping them out in a manner that's going to reduce the likelihood of a cave-in by essentially removing the trench wall itself. There's a couple of figures that you should commit to memory here. Those being 35 degrees over a slope of 1.5 to 1. Basically what you're looking for is a 1.5 foot vertical removal or horizontal removal for every foot of vertical in the trench on both sides of the trench. If you do that, you'll end up with a 34 degree from the horizontal slope on either side, which is unlikely to cave in, and that's the OSHA standard. So what does that look like? So if I got a 5 foot deep trench here, that means I got to have 7.5 feet cleared away on either side of the trench to get that 34 degree angle down here that is going to keep me safe. Obviously, the reason we have shoring and trench boxes is that in many cases there just isn't enough room to do the appropriate shoring. The appropriate slope cuts there. So make sure that this is not a place where you fudge things and go, oh, it's close enough. Cave-ins are really, really dangerous. Also, whether you're using a trench box or sloping or whatever, you got to have a ladder every 25 feet, and the ladder has to extend above the wall. It has to be placed firmly on the ground. These are the kind of things that frequently show up on tests. They're the kinds of things that are there to keep you safe. And these are not the kind of things that you really want to skirt. Again, don't be the headline. This is taken from a Michigan state publication. It's a list of things that had gone wrong, incidents in the prior year or two before this. Everyone, I looked at all of these case studies here, literally every one of them happened because the workers in question weren't following the rules, they didn't use the adequate protection, and in almost every case, the person who was trapped died. As I said at the beginning, people are bad at assessing risk. We get overconfident with outcomes when, prior risky behavior has not led to negative consequences. This is why we have the regs. This is why we have SOPs. This is why we have POP. This is why we have safety training. We don't want any of us to be the headline. You don't want to put yourself in danger. You don't want to put others in danger. So again, this has been a very, very broad overview, and again, not meant to scare you, but meant to make it clear that you work in a profession that is potentially dangerous, and it's really important to do everything you can to stay safe. There's a lot more hazards out there that we haven't talked about today. There are study materials available, both for test taking and on-the-job training as part of your safety program. Look at those materials, learn the procedures, commit them to memory, follow your safety program, and ultimately use your head. You see something, you say something. If something looks risky, and you got a bad feeling about it, trust your gut, do that second guessing, and make sure that things are being done in as safe a manner as possible so that no one gets put in danger. So that took a little bit longer than I expected. We've still got a few minutes for questions, if there are any, and I want to throw our contact information up here again as well. We are going to be implementing some office hours in the near future, where essentially AJ and I and some other members of our staff are going to be available to answer questions on the fly. We will be publishing those specifics when we get them. In the meantime, if you're interested in having access to those, you can visit our our EFC network website, or just shoot either AJ or me an email, and we will send you the link to our standing office hours. Those are going to go through at least the end of the year, and we'll be available to talk about pretty much any topic, whether it's something that we've covered in one of these webinars or not. The funding that provides these webinars and the various other training that we do also has funding for free technical assistance. It's your tax dollars at work. So if you have questions that you think we can help with, please reach out to us. We would be glad to help. So with that, I will open the floor, and for those of you who don't have questions or who have another meeting starting in 2 minutes, go grab a cup of coffee, enjoy the rest of your day. Thank you for joining us, and we hope to see you again at the next one.
Awesome. Thank you, James. And yeah, we're going to open up the next couple minutes for anyone that would like to put in any questions. We do have one question we received. With facilities becoming more automated, I've noticed a trend where facilities have staff reductions to only one operator. Do you have any studies, comments, or suggestions regarding incident and/or responses when an operator is working alone?
That is the sticky question. There are definitely some kinds of jobs that should not be done by a single person because of the inherent danger. Electrical work is one of them. Obviously, you can't do confined space entry with a single person. So the one limiting issue with that sort of approach, automation is great, but it does to some degree limit your ability to react to certain situations, because if confined space entry, for example, is required to deal with a specific problem and there's only one operator, you can't go in there, period, because it's dangerous and it's illegal. So, that is an issue with automation. There's always a balance point. I think in many cases, automating things is a useful approach, but you do have to recognize that there are going to be instances where a single operator is not going to be able to accomplish certain tasks because of the inherent danger. So yeah, I'm not necessarily in favor of automating everything and working with minimal staff. But again, sometimes, situations are what they are. So you just have to kind of adjust and make sure that, as the solo operator, you don't do something dangerous, just because you think like, oh, this will only take a minute. Because like I said, those trench collapse instances all happened because of people skirting rules. There's another incident I read about here recently, which I didn't show, where 3 people died because a guy went down into a manhole and passed out because there wasn't enough air in there, and the next guy ran in to pull him out and he passed out, and then the supervisor went in to get them out and he died. So that's a case where under normal circumstances or ideal circumstances, they should have been able to effect a good rescue if they'd followed the rules and been prepared. In this case, all 3 people died, but if that guy had been there by himself, the same outcome would have happened because there would have been no one to rescue them. So that's what I'll say on that. Don, feel free to chip in if you like.
And we just have one more comment. Someone said that they believe from a safety and risk management perspective, the buddy system should be a requirement.
Yeah, it really is. A lot of the work you do is inherently dangerous. All it takes is, a single slip to fall into a tank. And if you can't get out of it, you might not drown instantaneously, but that's going to be the outcome if there's nobody there to help you. So generally it's better to work in pairs if that's possible. And again, don't cut safety shortcuts if you don't have a buddy. It's better to postpone the work, even if that means, shutting down part of the plant or inconveniencing some customers. That doesn't kill people.
All right, a huge thanks to you, James, for sharing your expertise with us today. Following this webinar, each of you will receive a follow-up email with the slides from today and a link to the recording. We ask that you complete the webinar evaluation following the webinar so you can let us know your thoughts on today's sessions, as this helps us plan future webinars on topics that are important to you. Thanks again, everyone. We hope to see you at a future EFCN event.
Thanks again.